In these slides, we're going to talk about equilibrium and ocean acidification. All right, in class, you did a lab where you had a sample of water and you exhaled carbon dioxide into that sample of water. Meanwhile, you were measuring the pH level of the sample. And so what you found was that the pH decreased over time. In other words, as you were exhaling, the sample of water got more acidic. And so in the lab, you wrote down this diagram. And so we're going to go through this diagram and we're going to connect it with equilibrium. And so there's CO2 in the atmosphere. And so over time, since the Industrial Revolution, the CO2 in the atmosphere has been increasing because the modern society, we use energy to do a variety of things. And most of that energy is harnessed through the combustion reaction. And so extensively, we've talked about the combustion reaction throughout the school year. The chemistry doesn't end there. So once the CO2 is produced, it gets absorbed through the ocean, which reacts with water to make carbonic acid. And so the chemistry doesn't end there either. And then once the carbonic acid is made, it reacts with seashell, or this compound here, calcium carbonate, which is a component of seashell. So they react together, and you end up with calcium ion and bicarbonate. And so both of these cannot be used to use seashell, but this can be. But the carbonic acid destroys the calcium carbonate in the ocean. Okay, so as I mentioned, since the Industrial Revolution, there's been a drastic increase of CO2 in the atmosphere. And so equilibrium is if you increase a reactant, in this case would be CO2, you end up with more product. So CO2 is increasing in the atmosphere, and so the chemistry continues. So that means that more CO2 is being absorbed by the ocean, which reacts with water. So more calcium carbonate is being made. Not calcium carbonate, carbonic acid. And this more carbonic acid is reacting with calcium carbonate, which produces more calcium ion and bicarbonate. Now, notice that these arrows go both ways. So if you were to decrease, so if you think about this as a reaction going the other way, where this is the product, and if we were able to decrease the carbon dioxide, you would get equilibrium to shift towards the reactant in this case. And so these would come together, calcium ion, bicarbonate would come together, and you would end up with calcium carbonate and carbonic acid. And then carbonic acid would decompose into water and carbon dioxide, and then carbon dioxide would be going into the atmosphere.